Alright, for number 18, we have a rocket that's carrying fireworks. It's launched from an 80-foot hill, so it's being launched in the air and eventually hits the ground. So the question is, for part A and B, really it's tied together. They're asking at what time did it hit its maximum height and what was that maximum height? So here we need to find the maximum. And then part C is when did it hit the ground? So really you're finding when it hit the ground or the x-intercept. So for the maximum height, we have a formula opposite of b over 2a. So let's identify a and b. So a is the number in front of the t squared, so that's negative 16, and b is 64. So the opposite of 64 would be negative 64 over twice a, and we're plugging in negative 16 for a. So we would have negative 64 divided by negative 32, which is 2. So that means we know the x-coordinate is 2, or in other words, in 2 seconds, it's going to hit the maximum height. So right here is really 2 seconds. So we need to find that maximum height here. So how do we find it? We plug in 2 for t. So h of 2 means I am plugging in 2 for t. So negative 16 times 2 squared plus 64 times 2 plus 80. So the first term, we have to square 2 first. 2 times 2 is 4, and then multiply it by negative 16, which would be negative 64. The middle term should always be twice as big, an opposite sign, and if you multiply those, you get 128, and then plus 80. So if I combine negative 64 and 128, we're back to 64, and then plus 80, so that's 144. So therefore, the max height here is 144, so this would be 144 feet. So part A, to really answer it, let's see, I'm going to answer it right down here. So let's see, it said how many seconds after it was launched did it reach its max height, and what was the max height? After 2 seconds, it reached its max at 144, and the units are feet. Alright, part C, when did it hit the ground? So I'm going to erase some of this work because we're going to need room. So when did it hit the ground would be finding the x-intercepts. So we know that in order to find the x-intercepts, the equation has to be equal to 0 because the y-coordinate's always 0. So set it equal to 0, so we would have, negative 16t squared plus 64t plus 80. And then our options are either try to factor it and apply zero product property or jump to quadratic formula. I know in order to factor that it can't be negative in front of the t squared, so we said that multiplying both sides by -1 or just flipping all 3 signs works the same. So it becomes positive 16t squared minus 64t minus 80. Again, I'm skipping the step where you multiply both sides by -1. So if I were to factor this, I notice that we have pretty big numbers here. Hopefully we could find a common factor. And 16 actually divides 64 and 80, so I'm going to pull out a 16. So if I pull out a 16, I would be left with t squared minus 4t minus 5. And then what's left in the parentheses, if I could still factor that, I would have to continue. So this would be factoring method number 3, but no grouping because now t squared is just a 1. So it multiplies a -5 and combines to -4. Well, the factor pair would be 5 times 1, and we would need a negative on the 5. So my two factors are x minus 5 and x plus 1. And again, we still have that 16 in front of the first parenthesis. And then if I apply the zero product property, I'm really just changing both signs. I can ignore the 16 because it doesn't have a variable attached. So positive 5 and -1. So really, I changed the x's to t's, I was going to say. So really, this represents time. So this is t equals 5 and t equals -1. So we know that time can't be negative, so we could throw out the -1 answer. And we know that it hits the ground in 5 seconds. So right here in our picture, this would be at 5-0. So answer to C, it hits the ground. Let's see if I can write it here. It hits the ground in 5 seconds.